This diagram illustrates a chronological model spanning 8,000 years of history. Within this framework, a researcher has mapped 26 precise historical events that lock into a rigid structural sequence, converging on a single mathematical center. These are not approximations. Each of these 26 nodes aligns with an exact solar calendar day and a specific day of the week, which is synchronized perfectly to the orbital mechanics of our solar system. This chart compares that anomaly to a physical absolute. If you calculate the odds of this 26-node alignment happening by random chance, you arrive at 1 in 10 to the 88th power. For context, physicists estimate there are 10 to the 82nd atoms in the entire observable universe. In probability theory, Borel's law establishes a strict limit. Any event with a probability lower than 1 in 10 to the 50th power cannot occur by chance within the lifespan of our universe. Therefore, it is classified as physically impossible. To audit an anomaly of this scale, we must set aside theology entirely. We have to treat this timeline strictly as a deterministic data model and test it using Kolmogorov complexity and physical constraints. The primary challenge in long-term chronological mapping is calendar drift. Over millennia, microscopic rounding errors in human timekeeping accumulate into massive structural offsets. If you rely on the standard Julian year of 365.25 days to track history, you generate 62 days of error over an 8,000-year span. That much drift destroys the mathematics and makes it impossible to maintain an accurate weekday checksum. The solution to this drift is the fall day number, or FDN protocol. Instead of relying on shifting calendar labels, the FDN applies a continuous integer count to trace a mathematically straight line through history. This protocol operates on a single absolute constant, the true solar precision time year. It measures precisely 365.2421896698 days, grounded entirely in the deterministic orbital mechanics verified by Johannes Kepler. Applying the solar precision time constant eliminates the 62 days of drift entirely. It creates the stable mathematical foundation required for all 26 historical nodes to land flawlessly on their exact chronological coordinates. We can test the strength of this model by applying 4 increasingly strict tiers of probability. Under Tier 1, the skeptic standard, we drop the exact weekday requirement and reduce the test to just 20 events. Even then, the probability of these landing by chance is 1 in 10 to the 51st power, crossing Borel's physical impossibility threshold. That baseline probability is millions of times less likely than winning the Powerball jackpot 6 consecutive times. But the model demands the full codex standard, or Tier 4. This requires all 26 events to align with both an exact weekday and an exact calendar day simultaneously. Here, the calculation jumps to 1 in 10 to the 88th power. That figure is 1,000,000 times smaller than the odds of blindly reaching into the observable universe and selecting one predetermined atom. A convergence of this magnitude confirms we are not looking at a dataset retroactively fitted to history. These 26 points are the output of a functioning predictive algorithm. At this point, the mathematical auditor has to ask, is this dataset just overfitted noise, carefully curated from thousands of random dates? We answer that using Kolmogorov complexity, a computer science metric that measures the length of the shortest program required to generate a specific dataset. Random data cannot be compressed. If you wanted to specify 26 random dates across an 8,000-year span, your program would require a minimum of 558 bits of information. This visualization illustrates the reality of the data. The FDN model generates all 26 correct dates using a simple, recursive 11-bit algorithm governed by a strict 30-year administrative rule. Random noise compresses at a ratio of 1:1. A compression ratio of 49:1 is the definitive mathematical signature of a highly structured, designed system. Because the timeline yields to this level of compression, the 26 dates are not independent guesses. They are the inevitable, mathematically sound outputs of the underlying recursive rule. Imagine a pilot flying a cross-country route in zero visibility through a nighttime storm, relying entirely on the cockpit instruments to navigate. If that pilot attempts to fly 26 consecutive legs by dead reckoning without calibrated tools, minor deviations rapidly accumulate into a massive compounding error. Hitting 26 consecutive precision approach mixes at the exact required second, altitude, and position is mathematically impossible by chance. It only happens if your navigation instruments are perfectly calibrated to the actual architecture of the airspace. In this chronological model, the fall day number protocol and the solar precision time year function as that perfectly calibrated GPS and altimeter, navigating an ancient text's internal timeline. The model successfully clears the 10 to the 50th impossibility threshold. It passes the Kolmogorov compression test at a ratio of 49:1, and it executes an 8,000-year span with a zero-drift outcome. The mathematics leave no room for historical coincidence. We are observing a calibrated, deterministic,